Assalamualaikum and good day. I am Zikri Arif and I will present my progress as of today. In this crit 3, I will be focusing on the simulation of the facade that I have explored progressively from the previous crit 2. As from the previous crit 2, I have explained thoroughly on the recursive concept and the principle of stellation. To recap back, stellation is the process of extending a polygon in 2 dimensions, a polyhedron in 3 dimensions, or a polytope in n dimensions to form a new figure in the context of geometry. So based on the experimental models that I've made, new figures could be explored by extending and turning it inside out. So we can see here that the stellation principle has been applied from a cube to a rhombic dodecahedron, and from rhombic dodecahedron turned into the first stellation of rhombic dodecahedron. The optimum recommended and preferred illuminance level for an educational institution would be from the range of 300 to 500 lux, as it would greatly affect the occupants of the building if they have enough optimum daylight penetration. Form finding. So based on the crit 2 exploration on the urban grid, so first, in order to create a workable facade configuration, I used tessellation method to the basic cube from the previous initial idea and tried to arrange it in a manner that it will create interesting facade configuration. So by tessellating the cubes at each of their vertex, hexagon-like shapes made up of 3 planes are created. So from here, I extended another line from each of the cube vertex to form a perfect area of a tetrahedron-like shape, in which it is going to be the opening panels for daylight penetration. But before that, tessellation is actually repetition of shapes without any gap or space. So then, these tessellated cubes are orientated in such a manner that it is parallel to the proposed wall section of the building. So one cube that is tessellated in this configuration should represent as one facade module. So in this case, I named the first iteration of this facade system as cube V1 module. So for this cube V1 module, I have tried to be experimental with the opening panels, as it can be transformed into a few angles, and the one that I have explored are in 15-degree angle, 35-degree angle, and 70-degree angle. However, for this cube V1 module, it is impossible for the opening panels to have an angle more than 70-degree, because they are already creating another closed tetrahedron. So that means it will clash with another module. As such, to ensure that the daylight penetration inside the space of the building is at the optimum rate, this kinetic facade is designed with a mechanism to enable it to be open and closed with the responsivity to the position of the sun. So this allows the occupant inside the space of the building to get the desired amount of daylight. So let's go to the simulation. So the results of this cube V1 module facade could be seen here, with most of the areas are not receiving the optimum amount of daylight. So it can be seen in the force color diagram here that the green color is actually should be the optimum area where it receives the lux level between 350 to 500 lux. So in order to improve this, I tried to tessellate the cubes in another manner, that I arrange each cube vertex to meet the center of the central grid of the cube previously. So with that, the cubes are tessellated like Y shape when it is viewed from isometric view. So with the same opening panel concept before, this cube V2 module has been explored to only have a few opening angles with only 30-degree angle and 60-degree angle, because it is impossible to have greater angle than 60 degree, as it will clash with another module. So just like the previous cube V1, it also has this kind of limitation. So on to the results of the simulation. This cube V2 module facade could be seen that most of the area are just comparable to the results shown in cube V1. To be more specific, the lux level is not even reaching to a minimum of 200 lux per se. But what if we compare these two results of cube V1 and cube V2? So we can actually see from these results that the facade modulation that has the biggest opening, so in the case of cube V1, which is 75 degree, and for the cube V2, 60 degree. So the biggest opening does receive more light from the ones that have smaller opening for the daylight to penetrate inside. So with that, I tried to tweak the modulation design in such a way that the opening panels are made of solid plane, and the panel surface around it is going to be as a void, or further exploration of materials could be done, such as tensile membrane or fabric, or probably using a sustainable low E glass. So this modification will be applied to both cube V1 and cube V2 modules. So the reason why I tried to modify this cube V1 and cube V2 is because if we look at the previous result of cube V1 and cube V2, if we look at whenever the facade is not even open and it is stayed at 0 degree angle, so it is actually the facade act like a solid wall. So I tried to create a void, create an opening to the module itself, so that even though there will be openings to let the daylight penetrate inside the building, but at least the occupant is not reliant on the kinetic facade itself. So at least this one module facade, it has two system, where one is the glass or any other opening like tensile membrane, and another one is the kinetic opening facade that can be opened and closed. So the results of the modified modulation design of both cube V1 and cube V2 can be seen here. So in such a way that the area of the inside of these classrooms does receive more than 250 lux on average. So improvements can be seen in this force color diagram here. And by referring to the results of the facade configuration simulated today, another improvement is still possible to achieve for a better and more optimum daylight penetration into the building by scripting the cube V1 and cube V2 module configuration in Rhinoceros and Grasshopper software for better accuracy, instead of the fixed angles determined today. I mean, if you look at the cube V1, it has three fixed angles. One is 15 degree, 35 degree and 70 degree, and for the cube V2 we do have 30 and 60 degree. So by using Grasshopper and Rhino, so the hope to get a better result as we can get a better point attractor variables in Grasshopper itself. So how about this polyLAB in Punggol? So moving on to the building program of polyLAB. I have created two prominent group of zones. One is the communal and another one is the makerspace group. So as for the communal, we do have a specific zone for it, in which it will house a large display gallery and multipurpose area. As for the makerspace, this is the main learning area. So we have 5 distinctive zones, which is the collaborative zone, informal breakout zone, digital literacy zone, small group zone, and the makerspace zone. So we can see that the highlighted ones in the schedule are the proposed space that will have the priority and the benefit of being at the western side with the daylight responsive facade that we have seen and I have explored today. So with that, thank you.